Okay, so looking at the packet, we're looking now here at page 282. This is number 1A we're going to look at. And do a little sketch here quick. It's a little bit small there, but it'll work. So we're given the common rafter length of 13 feet and run of the common of 12. So what they're doing is, if the common, of course, remember, is when we cut right across here, we get this rafter. So they're saying this is 13, and the run, which is half the span here, is 12, which means the full span is 24. Now, we need to find, well, we could find the slope. It really doesn't matter here. We have all the information we need, because if the common rafter length is 13, that means this is 13 feet as well here, the longest hip jack. And since the run of the common is 12, that means this half span is also 12 feet. So then we can find the length of the hip corner here is just 12 squared plus 13 squared equals that squared. To find the next longest jack here, this is going to be 10 feet. So we have 12 goes to 10 as 13 goes to x. So we can find that length and subtract it from the 13 to get the difference. That's pretty much all you're supposed to find. Is they gave you the common.
I just couldn't picture it. Like, I couldn't put it together.
Okay. Sure. And then once you get to part C, they do a similar thing.
So does the
common rafter is this rafter goes from the peak down to the side, but it's the same as this longest jack if it's a conventional hip. If the slopes are the same, that longest jack is the same length. So now for part C, they give you that the slope is 612 and that the run of the common is 13 foot 6. So that means this is 13 foot 6 or 13 and a half feet. So now we're looking at this. This is 612. That means it's a 27 foot span because this is a 13 and a half foot run. And then from there you can find the height and you can find the length of the common here. And then you can use those. And that length of the common will be the length of this, and you can go from there. Is that all you needed? Okay. Any other questions on the hips or valleys for the conventional case, where the slopes are the same? Okay. Well, today then, we're going to look at the unconventional case. In an unconventional hip or valley, the slopes are not the same. So, when the slopes are not the same, we must deal with the decrease is going to be different on each side of that hip corner. So let's take a look. Draw my picture a little bit bigger because we're going to need some more details. And let's say that we have a roof here that is set up so the main roof here is a 612 slope and the hip roof is a 1012 slope. There are going to be a few extra steps in our process. We got to give you a span here. Let's say that the span here is 36 feet. Now, in the conventional case, the setback here, bless you, the setback here, which is the distance from the end to the peak, the horizontal distance, that setback is half the span. Well, since the slopes are not the same, that setback will not be half the span. It should be less than half the span because the hip slope is steeper. If the hip slope were lower, it would be more than half the span. But anyway, our step one is still going to be the common rafter. Remember, the common rafter is here in the main roof, so we're looking at taking a cut right there and looking at it. And it'll look like this. 36 feet, 612 slope, which means we're looking at this, which is going to be 18 feet. H is going to be 9, just because it's a 612 slope, the height is half the run. It'd be 6 over 12 equals H over 18. It comes out to be 9. And then we have to find the length of the common here is going to be the square root of 18 squared plus 9 squared. Oops, that's what I want. Giving us 20.125 feet. So that's the length of our common. That's right here. We need that length because remember there's going to be a different decrease on this side as there's on this side. That's going to be the main side decrease that we'll find with that length. Next, we need to find the setback. And the way we do that, let me grab my model. Even if the slopes are not the same, even if the slope on the side here on the main roof is not the same as the slope on the hip, the height here is going to be the same from here to here, right? Doesn't matter what direction you come, the peak is at the same height above the walls. So we have that going for us to help us find the setback. We found in this common rafter, we found a height of 9 feet. So if we look at it now from the end here, coming up here, we make that triangle, looks like that, going out to the hip. This height here is also 9 feet. So step 2, when we're dealing with the unconventional, is going to be to find the setback. We find that setback using the slope. It is a 10-12 slope. So 10 over 12, but now the height is the 9, that goes on top, and we are looking for x is the setback now. The run is what we're looking for. So it's 12 times 9 divided by 10, should give us 10.8. Correct?
No idea.
No idea? 10.8 feet. So now that we have that,
Well, on the
What's it?
diagram, that'll give you the ground in the middle.
that gives you this 10.8 feet. Now we'd have to find the brown. The brown is the slope. This up here is what we're looking for. This piece here is that slope part, the hypotenuse of that triangle. So that's going to be the square root of 9 squared plus 10.8 squared. 10.8 was correct, right?
Yep.
Okay. So second square root, 9 squared plus 10.8 squared. 14.058. It's 18 feet. So now we're going to go in each direction. We're going to find that next longest jack in each direction. So I'm going to do the main roof side first, and then I'll do the hip roof side. So the third step gets broken down. So on the main roof side, we have, this was 20.125 and 10.8. The next one, this will be X, and this is going to be 8.8 if we're still having a 2-foot spacing, correct? So that's going to give us 10.8 over 8.8 equals 20.125 over X. Cross multiply and divide. So 8.8 times 20.125 divided by 10.8. 16.398 feet. That's this one. This one. So now we have that. We're going to subtract that from the 20.125. And we shall get 3.727. That is the jack rafter decrease on the main roof side. 3.727 feet. Now we're going to convert that quick. 3.727, probably could have left the 3 off. So it's 3 feet, 8 inches, subtract the 8, times 16. 11, 12 sixteenths, so 3/4. 3 feet, 8 3/4 inches. That is the decrease on the main roof side. So every jack rafter is 3 foot, 8 3/4 shorter than the one before it. Make sense? Okay, now we're going to, what's that?
One of the homework problems, at the end, you convert it to a 16.
Yep.
Like 0.04 something.
So that's 0 sixteenths.
So what do you do?
Just put no sixteenths. It's just whatever the whole inches are, you just leave the whole inches. Yep, just leave the whole inches.
I don't know if we have to round up the line or what.
Nope, not unless it's over 0.5. So now we need to find this one here. We've got the 14.058 and the 18. This is the hip side. 14.058 and 18. The next one's going to be at 16 because of the 2 foot spacing, and that'll be our X now. So we've got 18 goes to 16 as 14.058 goes to X. We shall cross multiply and divide. 16 times 14.058 divided by 18. 12.496. So we're going to subtract 14.058 minus 12.496. We get 1.562. So on the hip roof side, it is 1.562. Or 1 foot. We're going to take 0.562 times 12 gives us 6.744. So that's 6. And it's going to be 3/4, but we'll go through the process. Times 16 gives us 11.9, so it's 12, so 3/4. 12 sixteenths or 3/4 of it. So on the main roof side, it is 3 foot 8 3/4. On the hip roof side, it is 1 foot 6 3/4. What do you think? Better than a sharp stick in the eye? Okay, so what I want you to do, let's see, trying to find the ones I'm looking for here. On page 300. Comes right after page 299. It's not numbered, but it's 300. Actually, it is numbered up there. On page 300, number 1, A through D. I want you to find the length of the hip rafter. I want you to find the main roof decrease. And the hip roof decrease.